Okay everyone, it's a mechanics. Today we're going to do resisted horizontal motion. Now in projectile motion, we ignored air resistance, which is the capital R, or drag. In resisted horizontal motion, they're back. So we will look at the consequences or impacts which air resistance or drag has for the vector of the forces and motion. Now what happens here? The higher the velocity of the object, the greater the resistance. So that the faster the object moves, it's harder to stop them. Okay, so let's have a look at this. The resistance causes the object to experience a retardation, which means the negative acceleration, which is they call deceleration. So it's like a decreasing velocity or speed. That's why you get the negative acceleration, because if it's increasing, it'll be positive acceleration. So for horizontal motion, only forces are the resistance to the velocity or to the velocity squared. Okay, so what happens? We're going to look at the two cases here. One is a linear resistance. Object is more likely moving at low speed. The drag, the pulling, is due to viscosity, the thickness, the thick of the medium. Okay, and whereas a quadratic resistance, which is I equals minus kV squared, object is more likely moving at high speed. Well, if you think about it, it's a V and it's a V square, so this will be a lot higher. So it's a bit more high speed. And the drag is due to the momentum transfer between the moving object and the fluid. So it's easier to get through quicker in the fluid than the thickness of the solid, isn't it? So that's what that is. Next one. Let's have a look at that. So the R equals, so we're going to use this the resistance force in terms of linear and quadratic, and change in terms of acceleration. Okay, so they say this to the right is a direction of motion. It is conventional to take the direction of the motion to be positive. So whatever it's moving, it's positive. So if a force was on this side, it's moving this way, that would be positive. But I'm just going to say this is positive. So I equals, because it's a resistance, it's always going opposite. That's why it's a negative, no matter it's a linear or quadratic. So minus kV. Now R is the resistance force. So I can just write it as a F equals minus kV. Of course, F is MA equals minus kV, and we can change into A equals in terms of A there. So same thing happens with when it's quadratic resistance. So let's have a look at the question. All right, particle of mass m, initially with a speed v0, moves horizontally. So that means we don't have to worry about vertical. Okay, against, so it's a negative, a resistance proportional to the square of the speed. So that's what we got. The whole this sentence sums up with minus kV squared. Express the velocity in terms of its displacement. That means a v of x there. Okay, traveled. So let's have a look. So draw the diagram. So we don't have to worry about the vertical. So it's only the horizontal part. So step anything to do with changing into A equals. Okay, so we start with R equals minus kV squared and F equals minus kV squared. That means MA equals minus kV squared, but change into Y because with the acceleration we can change this one in terms of V with X. So like you know, there's a v dv over dx, right? So we can use that. So that's why we need to, it's important to change into a equals. So if we did that, I'm going to just cover this one. So step 2 would be a equals v dv over dx, because the question says find the v in terms of x. So I've just done that, and I'll change the a into v dv dx. Now sometimes they will ask you to find the v in terms of t, then you have to use this, obviously. So we cancel the v on both sides, so I will have just now minus vk over m. And I just swapped the v and the dx, So now it's a dv over v equals minus k over m dx. I just swapped, because it's easier for me to integrate if I swap. So now it's 1 over v dv equals, now that's a constant, so I moved out of the integration there, and dx. So that's the ln log, and then I'll get the x plus c, the constant. And then let's have a look. When x equals 0, v was a vo, wasn't it? And therefore my c will be ln vo. So I'll just put it all back in, the c into the equation. That's what I'm going to get. Now we need to make the v the subject, so I'm going to move this one to here. It becomes like this, yeah? And then that's ln v over vo. To get rid of the ln, I take e, and I will get this on the right hand side, and then I'll divide by v0 on both sides. I will have v in terms of x. Okay, so that wasn't too bad. Now second question, let's have a look at the second question. Oops, I'm just getting a wrong paper to cover. So a particle of mass 5 kilograms is moved from the origin along the x-axis, so we're not going to worry about the vertical, only the horizontal part, with initial velocity of u meter per second. The only forces acting on the particle is the friction. Oh, that's good. So that's only the horizontal part, which is a constant 20 newtons, and a drag due to air resistance, which equals the v square newton, where v is the velocity of the particle t seconds. So there is some limits happening here. It started with the u at the beginning, initially, origin, and then after t seconds it becomes v. So be careful with that. Okay, it says after leaving the origin. Okay, so first one, it says show that equals this. So let's have a look. So I'll just sketch that. So we have the air resistance and also friction. So that's the diagram here. Again, first step is changing into a equals. Okay, so I'm going to go F equals, I've got these two, friction and air resistance. So I need to add them together, but it's in a different direction, so it's a negative. And I'm going to change the F equals MA and changing into that as required. All right, so that's not too bad. That was an easy one. And now this time I need to show that T equals the time. Okay, so you can see we have to use T, so we need to use this because that's a dt here. Okay, so let's have a look. So from A here, we got this. I've got dt over dv. So I just swapped because I want the t to my subject. So I just flip this. So therefore, this will flip. And then I'm going to integrate because I want it to be t equals. So if I do that, now this one is the inverse 10. I can see it 20 plus v squared. So if you do that, I will get this. Okay. Now here I had to add the limits because beginning it was u and it went up to the v after t seconds. So when I do that, I will get this. Okay. So I'm taking the constant out, so it'll be minus 5 over root 20. All right. Now what I've done here, can you see there was v take away u here, but I changed minus it. I'll put this one first, second, taking the negative out, and that becomes positive. Okay, so I swapped this around and the negative cancelled. Okay, so be careful about that. So now what happens, I'm just going to put it here, see if I could do that. So what happens here now, I will do, I will multiply root 20 over 5 on both sides here. So I'll get this, and I got rid of that. Okay, and then I'm going to take 10. Now when you see inverse 10 like this, you need to think about the difference of angles of 10. Okay, so I've got 10 there, 10 there. That becomes, it looks like 10 a minus b, difference of the angles, yeah? So that's the formula. And I'm going to call this part as my a, that part as my b. So when I do that, I will get in terms of 10a and 10b. So when I have that, I will be able to use this formula. So now I'll get 10a minus 10b all over 1 plus 10a times 10b. Okay, so that this is easy way of doing it. Now if I just times square root of 20 on the top and the bottom, I can cancel the denominator, so it's no longer a fraction. Okay, so on the top I'll just left with the u minus v. On the bottom I'll just expand this. I'll left with the root 20. I'll cancel one of them, and I still have uv over root 20. Okay, and I'm going to times by root 20 again to get rid of this. So I'm going to go root 20 times u minus v, that's okay. And here I'll times it like that. I will get 20 plus, get rid of it, uv. Okay, now I'm going to move the 10 on the other side because I want it to be t by itself. So one at a time I'm moving, so it becomes inverse 10. And then I'm going to times by the reciprocal of this. So that will be this, as required. Okay, so that wasn't too bad. It was a little bit of the skill involved here, like you need to times it. So what this does is just breaking it down into non-fraction. Okay, and also it sort of simplifies a bit more. All right, next one, the part C, by using dv over dt equals v dv over dx, find an expression for v squared in terms of x. Okay, now in the question some of them is just say v, find the v in terms of x. Okay, so I'll just put that at v2. They're sort of same because they both, if it's a v square x, same as v square, because they're both, it's going to be an x anyway. Okay, so don't worry too much. So I'm going to use dv over dt is that, so I'm going to use that one on there. Obviously what we've done is making this into one fraction, so that's what I've got. Okay, now here I didn't really wasn't happy with what I was doing, so I just changed it. So what happens here is I moved the 20 plus v square here. I swapped around with this. I swapped. So on the right hand side I still have minus 1 over 5, and I moved the 20 plus v square on the here, and then I moved the dx on the other side. Can you see what I've done here? So, and then I'm trying, because I know I'm going to have to integrate, because I have to make a v the subject, so I have to integrate. I want it to be v equals something here. So I know I need 2v here when I do that. So I'm just going to times 1 over 2 half and make into 2v. Stay in there. So when I integrate, I've got constant to be out, and then this, and you know it's going to be ln. and it's going to be minus 1 over 5 integrate dx. So when I do that, I'll get half ln 20 plus v squared equals that. Okay, and then I just, because I wanted this to be by itself, and I don't want to be half, because if you put half here, it's going to be a bit harder to simplify. So I'll just times by 2 on both sides, and that becomes that. And to get rid of ln, I just take the e. So that becomes 20 plus v squared, but e to the whole thing, the power goes to the whole thing. Now here, what happens here is, you can see it's like index law, isn't it? That means what? E to the power of minus 2 over 5x times e to the power of c. That becomes the e to the power of minus 2 over 5x plus c. Now that is constant. So I'm just going to make that constant is a. Okay, so then whole thing becomes like this. Yeah, can you see that? That becomes here like that. So a is really e to the power of c, whatever that is. And then initially x equals 0 and v equals u, because that's in the question. So I'm going to put it in, and when that it's 0 here, it's 1. So it'd be a equals 20 plus u squared now, because v becomes u at the start. So I'm just going to rewrite the whole equation here. Is 20 plus v squared equals, the a was 20 plus u squared in e to the power of minus 2 over 5x. So I'm just writing the whole thing in this form. And then I'm just going to make a v the subject, v squared, and then it'll become just minus 20. And that will be enough. Okay, so that's the end of the video. So that was a bit of a skill in algebraic skills a few times. So go over it again and watch it again, and make sure you understand the skills, and so you will be able to apply in the future questions. Well done.